So we're going to look at the amplitude, later on the period, and the phase angle. The amplitude means the highest value above or below the x-axis. So let's look at these graphs that have been sketched. Y is equals to sine x. You can see the value starts from 0. The highest value is 1, 90 degrees. Then to 180, then negative 1, then to 360. Now, then the graph starts repeating itself. It will just look like that all the way. It will be a wave, actually, if you were to continue. As long as the highest value is 1 or negative 1, which we generally say it is 1, whether it's negative or positive. So let's look at y is equals to sine x. The highest value is 1 all the way. Then what about y is equals to negative sine x? Now, this one, the values interchange. So this is a reflection of this graph. Y is equals to sine x is a reflection of this one in the x-axis. Why? Because for every value that you get, if the sine of 90 is 1, you multiply by negative 1, it becomes negative 1. If the sine of 30 is 0.5, comes negative 0.5. So the values interchange. Therefore, the values that were positive become negative. And the values that were negative become positive. So the amplitude is still 1. So the amplitude for y is equals to negative sine x, it is still 1, whether it's negative or positive. Now, if we consider y is equals to 2 sine x, for every value of sine x, we multiply by 2. So 1 becomes 2. 0.5 becomes 1. And so on and so forth. So we say the amplitude for y is equals to 2 sine x is 2, even if it is negative 2. The same with cos 2. The same with y is equals to 2 cos x. These graphs behave the same way. They are waves. But this does not apply to tangent, the graph of tangent. So let's look at y is equals to a half sine x. For every value of y, you divide by 2. So 1 becomes 0.5. 0.866 becomes 0.433. And so on and so forth. 0.5 becomes 0.25. So the amplitude for y is equals to a half sine x is a half. So therefore, we see the relationship between the coefficient of sine x and the amplitude. Therefore, if I may wrap this, and try to answer a few simple questions. What is the amplitude for A? Y is equals to negative sine x. The amplitude is 1. B, For y is equals to negative 3 cos x, the amplitude is this value. And we ignore the negative sign. The amplitude is 3. We ignore the negative sign. But let us look at part C. What about part C? Y is equals to 2 sine x plus 2. Now, of course, you will have said the amplitude is 2. But after getting the value of 2 sine x, we add 2. So the amplitude here is 4. Because this 2 is independent, it's not part of x, the amplitude is 4. The amplitude is 4. So let's answer other questions. What about D? If I may add, y is equals to negative 3 cos x minus 1. The amplitude is 4. Because there will be a time where the highest value is negative 3. Then you subtract 1, you get negative 4, which is 4. Which is 4. So what about E? Y is equals to 4 sine 2x plus 30. Now, still, these are in brackets. So this is part of 2x. 2x plus 30. The amplitude is still 4. The amplitude is still 4. Even if we change the sign to be negative, the amplitude will still be 4. So what is the amplitude, therefore? The amplitude, if you have drawn your graph, and it's a wave, the amplitude is the highest value along the x-axis, from here to there, or from here to here. The amplitude is the highest value up or below the x-axis. But there are situations that are interesting. For example, if you have drawn your graph, somehow the highest value here is negative 1, and here it is 4. The amplitude is the average. Here, the amplitude one divided by 2. The amplitude is equal to 2.5.